All right, so let's take a look at some general properties of ionic compounds. And overall, I would say ionic compounds are, for the most part, pretty kind of standard and boring. There's not that great of a variety between them. When we take a look at covalent compounds, we'll see that there's a much greater variety of those. But anyways, when we're talking about ionic compound, one thing that you have to realize is that the properties of the ionic compounds can greatly differ from their constituent elements. So what they were made out of is not the same properties as what it becomes. So I got a little picture for you here to demonstrate that. So on the left here, we have solid sodium metal, and it's stored in oil. So sodium is very soft metal. You could take like a butter knife and cut through it very easily. And the reason it's stored in oil is that it's very reactive to water. So Google up, alkali metals reaction with water. And then here we have a bottle of chlorine. It's a diatomic gas, right? So it's a yellow gas. And then when we combine these two together, we get sodium chloride, a substance you should be very familiar with because it's table salt. And if you think about table salt, it's actually very brittle. That's why it comes in like little tiny crystals. It's a solid, obviously, and it's very unreactive, right? If you put it in water, it doesn't blow up. It doesn't light on fire like sodium would. So you can see that the properties of an ionic compound greatly differ than the properties of their constituent atoms. Some other things that you should know is that ionic compounds have very high melting points and boiling points, and that's because these ionic bonds are actually very strong. So for example, table salt, sodium chloride, has a melting point of about 800 degrees Celsius. So that is very hot, very hot. Because of this kind of structure where they have these alternating cations and anions, they're very hard because everything wants to stick together, and that actually makes them very brittle. So they'll fall apart in kind of chunks. You can't you can't make it into a sheet. You can't roll it into a roll, something like that. They're very brittle. They'll fall apart. They're generally soluble in water. Not always, right? We've learned of precipitation reactions where ionic compounds are not soluble in water, but for the most part, they are. You'll learn about why later on. They generally have a crystalline structure. And so you think about, table salt, it's kind of very nice crystal. You'll learn more about that later on as well. And then in terms of electrical conductivity, it depends, right? So think about what electrical conductivity first is, and electrical conductivity is the flow of charge. And so we've got ions, so we've got charge. The question is, can this charge kind of flow? So let's take a look at examples of some of these. So I've got my little lattice. They should actually all be touching. It's just kind of a bad diagram. So in a solid, these ions can't move, and the ions are the charge. So in solids, ionic compounds are non-conductive. So the ions, which are the charge, can't move, and so they're non-conductive. What if you melt it down to a liquid? Well, then think about what a liquid is. A liquid, the ions are allowed, or the molecules are allowed to flow around. So this is a very bad picture of what a liquid would look like, but you get the point. So ions, which are the charge, are free to flow. And so this one is conductive. So when you melt it down to a liquid, it does indeed become conductive. And then the other kind of state that we want to think about is an aqueous state. So what happens when we dissolve it in a bunch of water? What happens when you dissolve in a bunch of water is that these ions essentially kind of separate from one another. You'll learn more about this later on. And so in this case, they are also free to flow. and thus conductive. So there's just some general properties of ionic compounds.